set of multiple values. But a dictionary.
So we will learn dictionary now. So sorry, I'm gonna put myself on the screen.
Allows you to associate something with something else. And notice, this is already more powerful, more interesting than a list. A list is just a set of multiple values. But a dictionary is sort of two-dimensional, if you will. Just like a human dictionary, a book, it associates something with something else, like words with their definitions. Now, what does this actually mean in practice? Well, suppose that we wanted to keep track of who is in what house at Hogwarts. Well, I could do it using lists alone. Let me go back to VS Code here, and let me just temporarily, but in a way that I'm not going to like ultimately, let me create another variable called houses, set it equal to Gryffindor, corresponding to Hermione's house, Gryffindor corresponding to Harry's house, and Gryffindor corresponding to Ron's house. And let's add Draco in there. So we now have 4 instead of 3 students, just so we have a little variety. And he was in Slytherin. So now we have 2 lists. And we could just agree amongst ourselves that whoever is first in the students variable lives in the first value in houses. Whoever is second in students lives in the second house. Who's ever third in students lives in the third house. We could do that. But honestly, that is going to break down quickly when we have a lot of students, when we have a lot of houses. And what if we want
So
to keep track of more things than that? What if we want to keep track of every student's house and the Patronus, this image that they conjure up magically? Well, then we need a third list. Like, this is just going to get messy quickly if we're just on the honor system using multiple lists where everything lines up logically. It doesn't end up well when your code gets more complicated. But I do want to implement this idea. I want to associate something with something. A student with a house, a student with a house, a student with a house, and so forth. So how can I go about doing this? Well, let me go back to my code here, and let me propose that we do this using a Python dictionary. And this is the last of the new syntax, really, that we'll see. Here's the new syntax. Instead of using square brackets, we're going to use curly braces for dictionaries as well. We've seen curly braces in the context of F strings. Completely unrelated. Sometimes you run out of keys on the keyboard and the authors of a language need to start reusing symbols in different ways. That's what's about to happen. We're using curly braces in a different way now. So let me create a variable called students. And let me go ahead and set it equal to open curly brace and close curly brace. This is an empty dictionary at the moment. And here's how a dictionary works. It allows you to associate something with something else. And you do that like this. Hermione, quote unquote, colon, and then the value thereof. What do you want to associate with Hermione? Well, Gryffindor. What do I want to associate Harry with? Well, I want to associate him with Gryffindor. What do I want to associate Ron with? Well, I want to associate him with Gryffindor. Well, this is actually not going to, this is going to get very ugly quickly. Once we add in Draco and Slytherin, my code is going to get too long. It's going to start wrapping. So this is purely aesthetic. It is perfectly acceptable in Python and other languages to format your code a little more readily and just add new lines if it makes it more readable. And one way of doing this might be as follows. I still have my curly brace up here. I still have my curly brace down here. But notice it's a little more readable now in that I have my keys on the left, my somethings, and my values on the right. Now in that I have my keys on the left, my somethings, and my values on the right, my other somethings. It's just a little easier to skim top to bottom. You could format it differently as well. But I'm going to go ahead and add in now Draco, who lives, of course, in Slytherin. So now I have each of these keys on the left and values on the right, which is really, again, just a code implementation of this idea, a little chart that you might write up with paper pencil when associating something with something else. So how do I now use this code in an interesting way? The syntax is almost the same. If I want to print out the very first student, Hermione's house, I could do this. Print out the name of the variable, but I need to go inside of the variable. I need to index into it. And what's neat about dictionaries is that whereas lists have locations that are numeric, 0, 1, 2, Hermione, Harry, Ron, respectively, dictionaries allow you to use actual words as your indices, so to speak, your indexes to get inside of them. So if you want to print out Hermione's house, the key you care about is quote unquote Hermione. And what this syntax here will do, notice it's not a number 0 or 1 or 2. It's literally Hermione's name. This is like going to the chart earlier and saying, all right, give me Hermione is my key, Gryffindor is the value. That's what we're doing here syntactically. We're looking up Hermione and getting the value thereof. So if I go back to my code, that should print out Gryffindor. And if I do this a few times, students bracket, quote unquote Harry should give me Harry's house. Print students, open bracket, Ron. That should give me Ron's house. And then lastly, if I do this with students, bracket, Draco students. And if I do this a few times, students, bracket, is my key, Gryffindor is the value. That's what we're doing here syntactically. We're looking up Hermione and getting the value thereof. So if I go back to my code, that should print students, open bracket, Ron, Draco's house. Now it's a little manual still. I bet we can improve this, but let me run Python on Hogwarts.py, and we should see Gryffindor, 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 Slytherin, which is exactly what we'd expect. Now all we've done again is we've just now moved from having just a simple list of names to, again, sort of 2 dimensions, associating, like we would on paper pencil, something with something else, keys with values respectively. Allow me, if you will, even though I realize this is getting a little fancy, allow me to escalate things slightly here and transition from looking at just, for instance, that pattern there, just hard coding those values there, to actually printing these out more dynamically. Let me go ahead and use our loop. And this question came up earlier as well. Let me go ahead and say for each student in students, go ahead and print out, for instance, the student's variable at, well, let's just say student first. Let's keep it simple. So this is not going to be that interesting yet, but when I run Python of Hogwarts.py and hit enter, notice, what should I see? Let me take a question here to see, what am I going to see when I hit enter now, when I'm doing for student in students?
Yeah, I think we would only see keys.
Perfect. So good intuition. It could have gone both ways. Could have been values, the houses. But when you use a for loop in Python to iterate over a dictionary, by design, it iterates over all of the keys. So we should see, I think, Hermione, Harry, Ron, and Draco. Let me hit enter now. Enter. And indeed, you're exactly right. We see just the keys. But that's not really that useful if what I really care about is who lives where. Can I print out both? Well, I think I can. Let me go ahead and do this. Let me print out not just the student's name, the key, but let me use the key, their name, to index into the dictionary. Right? If I know the word in the dictionary, let me look up its definition. If I know the student's name, let me look up their house. And the syntax for this, just like a list, is students, bracket, and just like in the past we used I, when I was a number, we can also, with a dictionary, use a string. So if the student's name is the key, then this syntax, students, open bracket, student, close bracket, will go to Hermione's location and get back her house. We'll go to Harry's location and get back his house, and so forth. So if I do Python of Hogwarts.py, enter, now I see Hermione Gryffindor, Harry Gryffindor, Ron Gryffindor, Draco Slytherin. Now it looks like I've given them all new last names, but I can clean that up. This is just a print thing. Let's go ahead and change our separator from the default space to maybe a space comma. And just using print features now, let me run the same program again, enter. Now I've just got some nice pretty commas in there to make clear that Hermione's last name is not, in fact, Gryffindor. But that's just a print detail. Any questions then on these dictionaries and what I've just done? Questions on these dictionaries and this looping over them here?
I just can't get my head around the for student in students. Does, if I'm, just correct me if I'm right, does that mean it imports the list of students and uses the indexes, or in other words, Hermione, Harry, and Ron, as the indexes in the actual the list of students?
Correct. So this is just a feature of Python. When you use a for loop with a dictionary, what happens is this. If this is the dictionary here with the keys on top and the values on bottom, you get to choose what the variable is called. I called my variable student just because it makes sense, because I want one student at a time. And what the for loop does, just like it did with numbers before, the 0, the 1, and the 2, it allows me to, for instance, set student equal initially to Hermione's name. And then the next iteration of the loop, the next cycle, sets student equal to Harry's name, then Ron, then Draco. It just kind of happens automatically. Like that is what the Python interpreter does for you when it sees a for loop like that. So it's very similar in spirit to iterating with a for loop over a list, but rather than iterate over the numeric location 0, 1, 2, it iterates over the bold-faced keys in this representation here graphically. And allow me to give us one other example on Hogwarts before we look at one other familiar domain. At the risk of things escalating a little bit, let me propose that we continue the story with one final Hogwarts example like this. What if we have more information about each of our students? And this is kind of inevitable, right? If you're implementing a program that's a database with people or customers or employees or anything else, you can imagine having a lot of data about anything you're representing in your program here. For the sake of discussion, suppose that every student at Hogwarts, of course, has a name. They have already a house, but they also have a Patronus. For those unfamiliar, this is the animal or entity that comes out of the end of their wand when they make a certain magical spell. The point here being is that we want to associate not just one thing with the student, but multiple things as well. Their name, their house, and their Patronus in this case. Well, what might code like this look like? Well, let me go back to Hogwarts.py, and let me start fresh for just a moment, and let me propose that I enhance this with a bit more data. And this data is going to look as follows. My students variable now, I'm going to propose we think of it as a list. What if we have a list of dictionaries as follows? Indeed, I want to literally implement this picture here. So notice that my previous picture just represented a single dictionary. But suppose I wanted to compose a list of dictionaries. That is, 4 students, so a list of 4 students. And suppose that each of those students is itself a dictionary, a collection of key value pairs, keys and values, something and something else. Well, here's one other way we can do this in code. Let me go back to VS Code here, and let me define a variable called students that is equal to a list. And I'm going to preemptively move my cursor onto separate lines because I know this is going to be long, and I want to fit all of the elements of this list inside of it. I'm now going to create a dictionary, one dictionary per student. And how do I create a dictionary? I just use those curly braces. But it's up to me to define what those keys are. And let me propose that one key this time won't be the student's name explicitly. It will literally be the word name, and they're going to have the name Hermione. This same student is going to have another key called house, and the value is going to be Gryffindor. And this same student is going to have a third key called Patronus, and the value of that is going to be, I had to look it up, an otter, according to the book. Now I'm going to create a second dictionary inside of this list. And again, a dictionary is literally like the human dictionary of words. It's a book that contains keys and values, words and definitions. What are the 3 words I'm storing in each of my dictionaries? Name, house, and Patronus. What are the definitions of those words for Hermione? Hermione, Gryffindor, and Otter, respectively. For Harry, the definitions are going to be different in this new dictionary. Let me give myself another pair of curly braces and say this. Name, quote unquote, colon, Harry. House here is again going to be Gryffindor. And this one I knew, his Patronus is going to be, in this case, a stag. All right, next, a third dictionary. The name here will be Ron. And I'm going to go ahead and do that just like this. Next, I have the house, and he too was Gryffindor. Lastly, how to look this one up, Ron's Patronus was a Jack Russell Terrier. Lastly is Draco in a fourth dictionary now, so another pair of curly braces. The name of the student is, of course, Draco. The house of this student is Slytherin. And Draco, interestingly enough, at least according to the internet, has no Patronus, was never revealed in the books or the movies. So it turns out, this is actually a wonderful teachable moment, there is a special keyword in Python that is literally none, N-O-N-E, with the first letter capitalized. This represents officially the absence of a value. So I could a little sloppily do something like quote unquote, but does that mean I didn't get around to typing it or not? It's a little clearer semantically to say literally none, a special keyword in Python to make clear that I know Draco has no Patronus. It's not just an oversight on my part. Now that I have this, what do I have in the computer's memory? I have a list. How do I know it's a list? Because I see a square bracket at the beginning and another square bracket at the end. That's just my visual clue. OK, I don't know necessarily what else is going on here, but there's a list of something. What is in that list? Well, here too, the syntax is our clue. Because this line 2 starts with a curly brace and ends with a curly brace, I just know that is a dictionary, a collection of key value pairs. Now, this all fit on my screen perfectly, so I didn't bother moving all of the key value pairs onto new lines. It would have made it really tall, so I kept it all together here this time. But how many keys does this first dictionary have? Put another way, in Hermione's physical dictionary, how many words are in that dictionary? 3. The words are name, house, and Patronus. What are the 3 definitions or values of those words in Hermione's dictionary? Hermione, Gryffindor, and Otter, respectively. And the same story goes for Harry, then for Ron, then for Draco. I have, by design, chosen to give them dictionaries that have all the same keys, all the same names, but they all have unique values. And that's my design. That's my prerogative as a programmer. So why is this useful at the end of the day? Now I have access to a whole collection of interesting data about all of these students. And I can still do a loop. I can say, for student and students, that's going to allow me to iterate over this list of students. And let me go ahead and print out just one thing at a time. Let me print out the current student's name. So as complicated as the dictionary is, this should be pretty comfortable. For student and students is just going to iterate over every student in the list. 1, 2, 3, 4 total. The next line is just going to print out the value of the name key. It's like opening a physical dictionary, looking up the word name, and giving us Hermione, Harry, Ron, and Draco, respectively, from each dictionary. So if I run this version of Hogwarts and hit enter, there, I get all 3 of their names. But what if I want more information than that? I want both their names and their houses. Well, just add to print's arguments, student, open bracket, house, close bracket. All right, let's go ahead and run this. Python of Hogwarts.py and hit enter. So I now see Hermione Gryffindor, Harry Gryffindor, and so forth. Well, we can aesthetically clean this up a little bit by adding a separator with print, like a comma and a space, just so that when I run this again, I now see some commas separating these values. But recall that students have not just a name, not just a house, but also that Patronus. So if we want to print out that too, we now have the syntax via which to go into that same dictionary for each student and output their Patronus as well as their house and their name. So if I run this program one final time, now I see all of the data in this here dictionary. So this is a lot to absorb all at once, I'm sure. It's the last of our new data types. On top of lists, we have these dictionaries. But again, a dictionary at the end of the day is just a collection of values similar to these values here that allow you to associate keys with values. And the first version of this program associated literally the students' names with their houses. But then I realized in my next version, wait a minute, what if every student has not just a name and a house, but a Patronus? Let's actually standardize the names of our keys to be name, house, and Patronus. And then the values of those keys can actually be the data, like Hermione, Gryffindor, Otter, and so forth. Questions now on these dictionaries and iteration thereof?
I just was wondering if the suppose the dictionary is very huge, and if I want to look up for a specific student, so how do I know where to look that student from? Like, can we sort it out in alphabetical order or numeric order or anything like that?
In short answer, yes. One of the features of Python is that it makes these dictionaries very highly performant for you. That is, even if they're very large, as they will be in future weeks when we manipulate more data, Python will find the data you care about quickly for you. And in fact, that is a feature of the language. That is a feature of a dictionary to get you the data quickly. And there are functions that you can use. You can sort the data. You can sift through it. You can do very performant operations, as we eventually will. Allow me then to propose, as we wrap up these loops, that we solve just a few final problems that will perhaps evoke fond memories of yesteryear, at least for me, wherein one of my favorite games growing up was this one here on the original Nintendo. And this is a two-dimensional world where the characters move up, down, and right, not so much to the left, in jumping over pyramids and obstructions like these. And allow me to propose that we use this just for inspiration, not to do something that's quite as colorful or graphical as this, but just to focus on, for instance, this barrier in the middle of the world here that Mario or Luigi had to jump over. And so this here seems to be like 3 bricks stacked stacked on top of one another. And we won't do things quite graphically, but let's just implement a very simple Python-based version of this textually using maybe just hashes for bricks. Because there's a pattern here, one on top of the other, and I bet we can solve this in any number of ways. Well, let me switch back over to VS Code here. And let me propose that we create a program called Mario.py using code in the terminal window. And then up here, let me start by implementing that same picture as simply as I can, printing out just literally the hash, and then the hash, and then a third final hash. This is going to be a very textual approximation of it, but I think if I run Python Mario.py, I've got a very simple version of that same column of bricks, so to speak. But you can imagine that certainly in a game where maybe these the columns get higher or lower, it would be nice to write code that's actually a little more dynamic than that and doesn't just use print, 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 which is literally copy and paste, it would seem. So let me at least adopt some of today's lessons learned and instead do something like this. For underscore in range of 3, let's now print out just one of these at a time. But the fact that I've now used a 3 to range means if I want to change it to something bigger or smaller, I change it in one place, not in 3 or more places. And this code, too, of course, if I got it right, is just going to print out the exact same thing. So we're iterating here. But let's see if we can't now integrate our discussion of writing functions of our own to begin writing something a little more dynamic and solving more complicated problems ultimately. One of the nice things about functions is that they allow us to not just write code that we can use and reuse, they allow us to create abstractions, if you will. An abstraction is a simplification of a potentially more complicated idea. And we've seen this a few times over the course of the weeks. For instance, we had a function called hello, which granted didn't do all that much. It just printed hello, but it allowed me to think about the function as exactly what it does. Not generically printing something, but literally saying hello. I've been able to get a number using something similar by defining my own function like getNumber. Well, let me go ahead and, for instance, assume for the moment that I've had the forethought to, in my function main, printing something, but literally saying hello. Hello. But it allowed me to think about the function as exactly what it does. Not generically printing something, but literally saying hello. I've been able to get a number using something similar by defining my own function like getNumber. Well, let me go ahead and, for instance, assume for the moment that I've had the forethought to, in my function main, use a function called print column. That seems as good a name as any to use a function that prints a column of bricks. Well, how can I go about now implementing this abstraction, this simple idea, print column, with actual code? Well, we've seen before with def, we can do just that. Let me define a function called print column. Let me accept as its input, generically speaking, a parameter called height. I could call it n or h, but I'll be a little more explicit now with height, just so I remind myself what it's doing. And now I think I can just borrow some of that same code from before. For underscore in range of height, go ahead and print out a single hash. And then at the end of this whole program, let's just call main. So I've kind of complicated the code. It doesn't do anything more just yet, but it's setting me up for solving what I think are going to be more sophisticated problems. If I run Python of Mario.py, we're back where we began. But I now have a function, an abstraction, print column, that's going to allow me to think about printing some chunk of the world of Mario at a time. And I can do this in different ways too. Notice that if I really want, I could do something like this. I could re-implement now print column in different ways, especially if I'm using print column all over my code, or maybe still a colleague of mine, a friend, someone else on the internet is using my print column function. What's also nice about functions you've written is you can change the underlying implementation details of them, but so long as you don't change the name of the function or its parameters or what it returns, if anything, no one else knows the difference. You can change the internal implementation as much as you want if you want to improve it or make fixes over time. So for instance, another way we could implement print column, recall, would be something like this, a bit clever with one hash and then a new line, and then maybe we could do multiplication of strings and then end this line with quote unquote. Again, it's okay if you're not comfortable with this syntax. This was a more clever approach we saw in the past. But if I run Python of Mario.py here, I'll still see a column of 3. But what's important here is that main does not need to know that the underlying implementation of print column has changed. Well, let's transition to a different dimension, if you will. And rather than print out just these vertical bricks, let's fast forward in the game to this part of the world here. At some part, Mario encounters these bricks in the sky that if he jumps up underneath, they become coins. And so he gains to his score. But let's go ahead and focus only on those coins. And let me propose that we print out, just these 4 question marks here. And let me go back to VS Code here. And let me propose that within VS Code here, just like before, we try to abstract this away. So let me go ahead and get rid of this version, because we're now going horizontal instead of vertical with our output. And let me just say, well, print row 4 times. Let me just abstract away the problem at hand. I don't know yet how I'm going to print those 4 question marks, but let's call it print row 4, and I'll assume I'll now solve this problem. Let's now go down that rabbit hole of solving the problem. Define a function called print row. It's going to take a width instead of a height, because it's horizontal instead of vertical. And how can I do this? Well, now we have an opportunity to do string multiplication even more elegantly. I can say quote unquote question mark times width. And this is a very pretty Pythonic way of printing what could otherwise be a loop, and that's fine. But this is going to go ahead and print those question marks for me. Let's do Python of Mario.py, enter. And now I've got 4 question marks. It's not nearly as pretty as the more graphical version, but it is at least a building block toward having now a reusable function like print row. And why am I doing all this? Like, why are we over-engineering the solution to these problems by having print column and print row? Well, it's a useful problem-solving technique as soon as your world does not look one-dimensional like this, or with the column version. But what about this? Later in Super Mario Brothers, does Mario have to jump down into this world where there's a lot of these underworld barriers? And this one here, for instance, looks like a square. It's 2-dimensional. There's a height and a width to it. And that is to say, there's a bunch of different ways we could implement this thing if maybe for discussion it's like a 3 by 3 grid, a 3 by 3 square of sorts. well, how can we go about solving this here problem? Well, let me propose we come back to VS Code, and let me propose that we think about this in a couple of different ways. I could do this, like this. If I know where I'm going, maybe I'm a seasoned programmer, let me go ahead and do this. Let me print out a square, the width and the height of which is 3. That's an abstraction. I'm just taking for granted for a moment that there is already a function called print square that's going to be width 3 and height 3 as well. But someone's got to implement this. And at the moment, there's only me at the keyboard, so let's go ahead and implement that square. Let me go ahead and define a function called print square that takes in a specific size, both for height and for width. And here's where we have an opportunity to use some of those loops. And we can use those loops in a way we haven't yet. If I want to print out all of these rows, but also all of these columns, I now have to think not just cyclically, like a loop allows, but I need to think two-dimensionally. And if you're familiar with like an old school typewriter, or even a printer nowadays, it generally prints from top to bottom. So even if you have multiple columns, you print out one line at a time. And while you're on that line, the printer or the typewriter prints from left to right. And that's kind of the mental model to have with your black and white terminal window. All of the output for every example thus far starts at the top and goes down to the bottom, from top to bottom, left to right. So we have to generate our output, our square, in that same way. So let me propose that we do this. Let me propose that we know we need to iterate this many times, 3 or more generally size. So let me do this. For I in the range of size, what do I need to do 3 times? Well, I want to print out what? 1, 2, 3 rows of bricks. But within each row of bricks, what do I want to print? 1, 2, 3 bricks specifically. So if we go back to our diagram here, and I stipulate that it's indeed meant to be a 3 by 3 square, 3 wide and 3 tall, what do I want to do to print the first row? I want to print brick, 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 brick. What do I want to print on the second row? Brick, brick, brick. And the third row, brick, brick, brick. So I'm doing 3 things 3 times. There's a lot of printing that must happen. So let me go back to my code here, and let me propose now that we think of this outer loop that I've just started as representing each of our rows. For I in range of size is going to ensure, no matter what I do next, that I can print out 1, 2, 3 rows, or more generally, size, where size could be 3, but it could be smaller or larger. What do I want to do on each of the rows? Well, just like an old school typewriter or printer, on each row, I want to print out brick, 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 brick. Well, that sounds like a cycle, some kind of loop. So maybe I can have inside of one loop another loop. I don't want to use I again because I don't want to use the same variable and mess up my counting. So I'm going to, by convention, use j. Very common to use I and then j, maybe k. But after that, you shouldn't keep nesting inside of each other. Let me go ahead and say for j in range of size 2, because it's a square. And then each of these rows, let me print out a single hash, but no new line. But after each row, let me print only a new line. So there's a lot going on here, especially if you've never touched Python, let alone loops. But notice what I've done here too, and I'll add some comments for clarity. For each row in square, for each brick in row, print brick. And here is where comments, and more generally pseudocode, can really help explain to yourself and to others what your lines of code are doing. On line 8, I'm iterating from I equals 0 on up to size, so 0, 1, 2. On line 11, I'm doing the exact same thing but using j from 0, 1, 2. But that's good because I represents now each of my rows. And while I'm on each of those rows inside of this outer loop, I'm going to do brick, brick, brick. 1, 2, 3, 1, 2, 3, 1, 2, 3. But I don't want my cursor to keep moving to the next line while I'm on a row. So I'm just overriding that line ending. But let me ask a question of the group now. Why on line 16 do I have a print here all by itself? Why do I have a print all by itself? Notice that it's below the inner loop, but inside of the outer loop, so to speak. What is that loop on line 16 doing, ultimately?
Every time you finish a line, you have to add a new line at the end of it. So
Perfect.
it prints a new line.
Perfect. I don't want a new line after every brick. I only want to do that at the end of the row. And that's why my comments now are perhaps enlightening. Notice that this loop here is just iterating for each brick in the row. Once I'm done with that inner loop, so to speak, once I'm done with these highlighted lines here, to Evelyn's point, I need to print out one blank new line. And we've not done this before, but when you call print with no arguments, all you get is that automatic line ending, the \n, where the cursor moves to the next line. So if I now go back to my terminal window and run mario.py, I think I should get a 3 by 3 square. And it doesn't quite look like a square on my screen because these hashes are a little taller than they are wide, but it is, in fact, 3 by 3. But let me propose, as we've always done here, how we might tighten up this code further. Just for clarity's sake, let me get rid of my comments for a moment, just so we can see how many lines of code we have total. And let me propose that we maybe do this. let me propose that, you know what, this inner loop, especially if you're having trouble wrapping your mind around one loop inside of another loop, you don't strictly need it. What if we do this trick again? What if we print out inside of the outer and only loop each of those hashes times the number of times we want them, right? We draw inspiration from an earlier approach and we run total. And let me propose that we maybe do this. Let me propose that, you know what, this inner loop, especially if you're having trouble wrapping your mind around one loop inside of another loop, you don't strictly need it. What if we do this trick again? What if we print out inside of the outer and only loop each of those hashes times the number of times we want them? Right? We draw inspiration from an earlier approach, and we run Python now of Mario.py, same result, but now print square is really nice and compact. It has one explicit loop, and it's still printing out using string multiplication all of the hashes at once on that row. If you like abstraction and you'd like to wrap your mind more around what the code is doing, well, let's do this. If you're not quite clear on what's going on, let's propose that you implement a function called print row, passing in size. And let me propose that this print row function, it simply take in that width and print out the individual hash times that many times. In other words, here's an opportunity for abstraction, whereby, well, what does it mean to print a row? Well, when you're implementing print square, I don't really care what it means to print a row. I just need to know that someone's taking care of printing the row. You can kind of pass the buck to another function altogether. And how does print row work? Well, it could use a for loop. It could use this string. Implementing print square, I words in that called print row, passing in size. And let me propose that this print row function, it simply take in that width and print out the individual hash times that many times. In other words, here's an opportunity for abstraction, whereby, well, what does it mean to print a row? Well, when you're implementing print square, I don't really care what it means to print a row. I just need to know that someone's taking care of printing the row. You can kind of pass the buck to another function altogether. And how does print row work? Well, it could use a for loop. It could use this string multiplication trick. This is a way to take a larger program, and this is probably the most complicated one we've looked at thus far, and to decompose it into these smaller components that, once assembled, achieve your final idea. Seeing no questions, that's the end of our look at loops in Python, this ability to do things cyclically again and again. And when we combine those with conditionals, this ability to ask and answer questions and combine them with our functions and variables, we really now have most of the building blocks we need to solve much larger, much more interesting, much more personal questions. So in the weeks to come, we'll start to see exactly what could go wrong, though, when we do so, but we'll introduce you to all the more tools by which you can troubleshoot those same problems.
Alright, I'm gonna end the stream now. It's pretty late, so